Okay, we're going to do mathematical induction. There's basically 3 ideas behind mathematical induction. The first idea is that you're going to try to prove that it's true for the very smallest case, which in this case it's n equals to 1. So what I do is I write out the left side and the right side of that equation, and I basically try to prove it's true. That's why there's the question mark. So here's the first case where I'm just setting the first piece equal to the last piece. So then I reduce down, is the left side 1/2 equal to the right side, which is 1/2. And because it's equal, then I'm happy because I've done the first step, proving the smallest case. The second step is assume that n equals to k works. K is just some random case, any number. So I'm just going to use k for example. And then prove that it's true for the very next case, which would be k plus 1. So all I do is, in this case, and for this step, I'm going to replace all of the n's in this set right here to be a k. So I write out everything, and so that's true. And so I'm assuming that it works, because if I assume that this works and prove it for the next case, essentially I proved it for all cases starting with 1 and then continuing on to virtually infinity. Okay, so again, this works. This is true. So now what I'm trying to do is I'm trying to prove that k plus 1 works. So what I'm going to do is I'm going to write all this out. This is what we've already proved. We know what this is, right? This thing is, we already know, right? We knew it from before. We know that it's going to be k over k plus 1. But then we're trying to prove it for k plus 1, so now we're going to prove it, write that very next term in. So again, instead of writing n right here, I'm going to write k plus 1, and then now it's k plus 1 plus 1. Again, this is, and then reducing that down, k plus 2. Again, don't be intimidated by this. I know that that's oops. And I know that this is my new n, and that's my new n. And so all of these are still my n's, and we're just moving forward. And again, I'm just reducing here so it makes sense. And then I just reduced here, k plus 2. And I know what this is. This was from that assumption step. So I'm going to write in that that whole thing is equal to k over k plus 1. And we did that in that last step. So now all I'm trying to do is I'm really just trying to get this side here to look exactly like this side here. So the first thing that I notice is that I'm adding fractions, and because I'm adding fractions, I need a common denominator. This is the same as this, so I need to multiply by k plus 2 to get that piece. So I multiply k plus 2 plus 2. And then once I have that, my new denominator is k plus 1 plus 2, k plus 1, k plus 2. And then I have this piece here, k times k plus 2. And then I have this 1 right here, right? So now what I want to do is, I don't know, it's not looking anything like this. So I'm just going to keep simplifying. So the denominator stays the same. And the top, now I can distribute, looks like k squared plus 2k plus 1. And you should recognize this as your as something that you can factor. So I'm going to factor that. And it turns into k plus 1 times k plus 1. Again, the denominator staying exactly the same. Now, if you notice right here, those two are exactly the same. So those are going to cancel. Now, I can't do anything else here, but I do notice that those two are exactly the same. And so now I have that k plus 1 over k plus 2 is the same as k plus 1 over k plus 2. That's it.